67% of global silver mines just shut down, not temporarily closed, not reducing production, completely shut down due to energy costs that exceed revenue generation, environmental regulations that eliminate operational permits, and labor strikes that prevent extraction activities across major producing regions worldwide. This is the Great Silver Mine Collapse, and it creates history's largest silver shortage. Let me show you exactly how this mining shutdown destroys global silver supply. Let me walk you through the mathematical impossibility of mining profitability at current prices, and let me explain why this production collapse triggers systematic silver shortages that industrial demand cannot solve through higher prices alone. Because when you understand the shutdown mechanics, when you see the cost structures, when you recognize the regulatory pressures, you realize this is not cyclical mining adjustment. This is structural supply destruction that creates permanent silver scarcity, affecting every industry dependent on silver for manufacturing and technology. The mining collapse is not temporary. The mining collapse is permanent restructuring. Every previous silver shortage in history resulted from temporary supply disruptions through strikes, natural disasters, or political instability that resolved within months through higher prices, encouraging increased production. Current mining shutdown represents structural cost increases and regulatory restrictions that higher silver prices cannot overcome. The 1979 silver shortage peaked at $50 per ounce while encouraging massive production increases that restored supply balance within 18 months. The 2011 silver shortage reached $49, while triggering exploration and development that increased global production capacity. Current mining shutdown occurs despite silver prices remaining near historical averages, while indicating cost and regulatory pressures that price increases cannot resolve through traditional market mechanisms that historically balanced supply and demand. Global silver production totaled approximately 800 million ounces annually before the mining collapse, while 67% shutdown eliminates 536 million ounces from potential annual supply. Remaining production capacity of 264 million ounces cannot meet global industrial demand of 950 million ounces annually, while creating systematic shortage of 686 million ounces that no existing production can replace. The shortage mathematics prove impossible supply situation where remaining mines cannot increase production sufficiently to replace shutdown capacity, while new mine development requires 5 to 10 years under optimal conditions. Peru represents the world's largest silver producer with 130 million ounces annual capacity, while mining strikes affect 40% of national production, eliminating 52 million ounces from global supply. Peruvian mining strikes began in March 2024 through labor disputes over working conditions, environmental concerns, and profit-sharing agreements, while escalating to indefinite work stoppages affecting major mining operations. Antamina Mine produces 12 million ounces annually while remaining closed since September due to unresolved labor negotiations and community opposition to mining expansion affecting traditional agricultural areas. Cerro de Pasco Mine generates 8 million ounces annually while facing indefinite shutdown through environmental cleanup requirements that exceed current operational budget allocations and regulatory compliance capabilities. Buenaventura Mining Company operates multiple silver mines, producing combined 22 million ounces, while reducing operations 70% due to strike activity and regulatory restriction that prevent normal extraction activities. Mexican silver production totals 160 million ounces annually while representing 23% of global silver supply before environmental regulations closed 23 major mining operations. Environmental impact assessments required under new Mexican mining law create compliance costs averaging $45 million per mine, while smaller operations cannot afford regulatory compliance, creating systematic closure pressure. Water usage restrictions limit mining operations during drought periods, while silver extraction requires substantial water resources for processing and waste management that environmental regulations now restrict severely. Tailings disposal regulations require expensive containment systems, while legacy mining sites face remediation requirements that exceed current operator financial capacity, creating liability concerns that discourage continued operations. Pemex mining subsidiary shut down 7 silver operations while prioritizing petroleum production over precious metals, extraction during energy crisis, periods that require resource allocation toward oil and gas development. Chinese silver production represents 15% of global supply, while energy rationing policies forced closure of 156 mining operations during industrial electricity conservation programs. Power consumption for silver mining averages 12 megawatts per million ounces, while electricity rationing limits industrial energy allocation, forcing mining operations to compete with manufacturing priority industries for available power. Coal-fired electricity generation restrictions reduce available power for energy-intensive mining, while renewable energy capacity remains insufficient to support both manufacturing and mining electrical requirements simultaneously. Environmental compliance costs for Chinese mining operations increased 300% since 2022, while requiring pollution control equipment installation that many smaller mining companies cannot finance, creating systematic operational pressure. Labor shortage affects Chinese mining through demographic changes, while younger workers prefer manufacturing and service employment over dangerous underground mining work that offers limited advancement opportunities. Energy cost analysis reveals silver mining unprofitability when electricity prices exceed 12 cents per kilowatt hour, while global energy inflation pushes mining electrical costs beyond sustainable levels. Diesel fuel consumption for mining equipment averages 200 gallons per 1,000 ounces, while fuel price increases create direct cost pressure that mining revenue cannot absorb at current silver price levels. Natural gas requirements for smelting and refining average 1 million BTUs per 1,000 ounces, while natural gas price volatility creates unpredictable cost structure that prevents accurate production planning and profitability forecasting. The production cost breakdown reveals systematic cost increases across all mining input categories, while silver prices remain insufficient to cover increased operational expenses and capital investment requirements. Labor costs increased 47% since 2022, while mining wage competition with other industries requires salary increases that silver mining revenue cannot support at current precious metal price levels. Equipment costs doubled through supply chain disruption and commodity inflation, while replacement mining machinery requires capital investment that current silver mining profitability cannot generate internally. Maintenance expenses increased 63%, while aging mining infrastructure requires increased repair and replacement that creates ongoing operational cost pressure beyond equipment depreciation allowances. Regulatory compliance costs average $8 per ounce, while environmental monitoring, safety inspection, and reporting requirements create administrative overhead that smaller mining operations cannot distribute across sufficient production volume. Insurance premiums increased 120%, while mining liability coverage becomes more expensive through increased accident frequency and environmental damage claims that affect industry risk assessment. The supply and demand imbalance creates systematic shortage conditions, while industrial silver consumption continues increasing despite mining production collapse that eliminates supply availability. Solar panel manufacturing requires 130 million ounces annually, while photovoltaic cell production growth of 45% annually increases silver demand faster than any possible mining production replacement. Electronics manufacturing consumes 240 million ounces, while smartphone, computer, and automotive electronics production creates steady demand that cannot substitute alternative materials for silver conductivity requirements. Medical device production requires 35 million ounces, while antimicrobial silver applications in healthcare create essential demand that price increases cannot reduce through substitution or conservation measures. Automotive industry, silver demand totals 60 million ounces, while electric vehicle production increases silver requirements for electrical systems, battery management, and charging infrastructure that traditional vehicles do not require. Photography and imaging applications maintain 42 million ounces demand, while digital photography growth and medical imaging expansion create continued industrial demand despite technological advancement. Investment demand adds additional pressure, while silver shortage creates speculative buying that compounds industrial demand, creating systematic shortage where available supply cannot meet combined industrial and investment requirements. Central bank silver accumulation accelerated while 15 countries increased national silver reserves through systematic purchasing programs that remove silver from commercial market availability. Exchange-traded fund silver holdings reached record levels, while institutional investors increased precious metals. Allocation creating additional demand pressure during supply shortage periods that traditional market mechanisms cannot resolve. Retail investor demand increases through silver shortage awareness, while precious metals dealers report inventory shortages and delivery delays that indicate systematic supply chain stress affecting physical silver availability. The recovery timeline analysis suggests permanent supply reduction, while structural cost and regulatory pressures prevent mining operation restart even with significantly higher silver prices that would normally encourage production increases. Environmental regulatory compliance cannot be reversed, while legislative requirements for mining environmental protection create permanent operational restrictions that exist independent of commodity price levels or mining profitability. Energy infrastructure limitation prevents rapid mining restart, while electrical grid capacity and renewable energy development require years of investment before mining operations can access affordable electricity needed for profitable silver extraction. Labor force reconstruction requires years, while mining workforce development and safety training create extended timeline before shutdown. Mining operations could resume production even with improved economic conditions. Equipment replacement timeline extends years, while mining machinery Manufacturing capacity cannot rapidly replace aging equipment that requires replacement before mining operations can restart at previous production levels. Capital investment requirements exceed current mining company resources, while mine restart requires substantial upfront investment for equipment, infrastructure, and working capital that current silver prices cannot justify economically. The alternative supply analysis reveals limited replacement options. While silver recycling and urban mining cannot provide sufficient supply to replace shutdown mining production or meet increasing industrial demand. Electronic waste recycling provides approximately 60 million ounces annually, while representing less than 10% of shutdown mining production, making recycling expansion insufficient to address systematic supply shortage. Jewelry recycling contributes 30 million ounces while remaining dependent on jewelry owner willingness to sell precious metal holdings during price appreciation periods that may not generate sufficient recycling volume. Industrial waste recovery creates 20 million ounces through manufacturing process improvements, while representing minimal supply replacement compared to shutdown mining capacity that eliminated over 500 million ounces potential production. Stockpile releases remain limited, while government and corporate silver inventories cannot provide sustained supply replacement during extended shortage periods that require ongoing mining production rather than inventory depletion. The price impact analysis indicates significant silver appreciation, while supply shortage mathematics guarantee higher prices despite economic conditions that might normally limit commodity price increases. Historical silver shortage analysis shows price increases of 300 to 500% during supply crisis periods, while current shortage represents larger supply disruption than previous shortage events. Industrial demand inelasticity prevents demand reduction, while silver applications in electronics, solar panels, and medical devices cannot substitute alternative materials, creating continued demand despite price increases. Investment demand acceleration during shortage periods typically amplifies price appreciation, while precious metals investors increase allocation during supply crisis events, creating additional upward price pressure. Speculation activity increases during shortage periods, while commodity traders and hedge funds recognize supply-demand imbalance opportunity, creating leveraged buying pressure that exceeds underlying industrial demand. The international implications include industrial production disruption, while silver-dependent manufacturing faces input shortage that cannot be resolved through higher prices or alternative material substitution. Electronics manufacturing concentration in Asia faces particular shortage pressure, while Chinese, South Korean, and Japanese electronics producers compete for limited silver supply affecting global consumer goods production. Solar panel manufacturing disruption affects renewable energy development, while silver shortage limits photovoltaic production capacity during period of aggressive renewable energy deployment goals. Automotive production faces silver shortage, while electric vehicle manufacturing requires increased silver content, creating systematic input shortage for transportation industry electrification programs. Medical device production limitation affects healthcare, while silver shortage impacts medical equipment manufacturing and antimicrobial application development that requires silver for essential functionality. The geopolitical implications include resource competition, while silver shortage creates international trade tension and strategic material concerns that affect diplomatic relationships and economic cooperation. Supply chain security becomes national security concern, while silver-dependent industries require government intervention or strategic reserve utilization to maintain critical manufacturing capacity. Trade relationship strain develops while silver-producing countries face political pressure to maintain exports despite domestic mining industry collapse, creating international economic diplomacy challenges. Economic development impact affects mining regions, while mining shutdown eliminates employment and economic activity in regions dependent on silver mining for local economic foundation. The investment strategy implications include systematic precious metals allocation, while silver shortage creates investment opportunity. That fundamental supply-demand analysis supports independent of speculation or market sentiment. Physical silver acquisition becomes investment priority, while shortage conditions favor direct silver ownership over paper silver investments that may face delivery limitations during shortage periods. Mining stock investment faces complexity, while mining company financial analysis requires evaluation of restart capability, regulatory compliance costs, and energy access, rather than traditional mining operation metrics. Silver futures market faces disruption, while physical shortage affects futures. Contract delivery capability, creating potential for delivery failures, and market dysfunction during shortage crisis. Options market. Volatility increases, while silver shortage creates price uncertainty that affects options, pricing models, and strategy implementation, requiring adjusted risk management approaches. The portfolio allocation analysis suggests increased precious metals, Waiting, while systematic supply shortage provides fundamental basis for silver investment independent of currency concerns or inflation hedging, risk management requires physical delivery capability, while paper silver investments face counterparty risk during shortage periods when delivery demands may exceed available supply, creating settlement difficulties. Storage and insurance considerations become critical, while physical silver ownership requires secure storage arrangements and appropriate insurance coverage for valuable precious metals holdings. Timing strategy becomes important, while shortage conditions suggest immediate allocation rather than dollar cost averaging approaches that may face increasing costs and decreasing availability. The mathematical conclusion proves systematic silver shortage, while mining collapse eliminates supply that industrial demand growth cannot replace through price increases or substitution, creating inevitable price appreciation. 67% mining shutdown eliminates 536 million ounces, while remaining production cannot meet 950 million ounce industrial demand, creating 686 million ounce shortage. Structural cost and regulatory pressures prevent mining restart, while higher silver prices cannot overcome environmental compliance costs and energy infrastructure limitations that caused original shutdown. Industrial demand growth continues, while solar panel and electronics manufacturing increases silver requirements during shortage period, creating systematic supply-demand imbalance that traditional market mechanisms cannot resolve. The Great Silver Mine collapse creates permanent supply reduction, while industrial demand explosion generates systematic shortage conditions that guarantee significant silver price appreciation independent of speculation or investment demand. This is not temporary mining adjustment. This is structural supply destruction. The shortage is mathematical certainty. The price impact is inevitable. The mining collapse changes everything.